Now that the majority of the track is laid, I'll give you a quick tour around. That's the track over the lifting section, and then successfully managed to join the tracks up there with a tiny gap. Small stations going in there. Around to here we've got the crossing, and then the goods yard is going in here. I'm going to be buying that at a later date, and also the turntable to go in here. I've got some bits to add on in there. Then we've got the curved crossover to there, which leads to the tunnel siding and the station area. You'll notice there's a bit of card under there. Despite my best efforts, the plywood surfaces don't quite meet flush. There's about a 1mm gap, so I'll put a bit of card under there just for support for now, but ultimately ballasting will cover that gap and secure the track in place. We've got the programming siding in here, station area, as I said, in there, and then round here, and the TMD is going to go in here, and that's going to be done at a later date. As explained in the other video, are pre-drilled holes for all the points, ready for the point motors to go underneath. And if you can just see there, there's a hole there ready. There's only one area where I couldn't drill a hole for the point motor, and that's this point here, because it sits over the batten where these two panels meet. But it clearly was a big advantage in having a track layout already thoroughly planned, so that I could plan them where the battens would go, and virtually all of them, well, all of them do miss apart from that one, which was unavoidable. So all the others, there's plenty of space for the point motors. Now the last section to go in is this south section, which passes the TMD, with a join up the bridge section over there to the outer and inner loops in there. And in the middle of here is going to be an express crossover, which has Peco electrofrog points. The difference between this and the insulated frog points is, because I intend to use point motors with the frog powered by the switch, I have to cut the wires and do the soldering as I explained in a previous video. But once I've done that, I can't run locos over it without the point motor, because the frog won't be supplied with power. So I have to fit the point motors at the same time that I lay those tracks down. So this video is going to be showing you what I've done to prepare for that. Those wire bridges on the bottom of the point I've just removed, and actually, although it talks about cutting them, they're just very lightly soldered into place and they just pull straight off. And now I'm going to solder some wire across those contacts to provide a permanent connection to the rails there. There's some wires between the rails. Not the neatest soldering job in the world, but it's below the level of the track, and some good ballasting should cover that up in due course. I'm going to be using point motors for the first time, so rather than go straight into putting them on the board, I've built this test bed, which is a piece of the same 9mm ply, and I've got on here a Peco electrofrog point from the Streamline range, which is the express point, and some leftover pieces of flexible board just to extend it. As outlined earlier, one of the things Peco provide is a wire connection for the frog, and that's there. And I've pre-drilled a hole for the point motor. Now you can see what I've got here is some Velcro. I'm aware from doing bits of carpentry that adjusting position of screws after they've been drilled is really difficult. If you try and move a screw by a couple of millimeters, once it's in place, you've got no chance, it's going to go straight through the hole. So adjusting the position of the point motor after it's been fixed is really difficult. And I read online that Velcro can work well for positioning, so that'll go under there with the control bar through to the point underneath. This is the point motor, the Seek PM1. It's a solenoid motor, like many of them. It's got two electromagnetic solenoids with an iron bar in the middle, which has the point wire running through it that moves the point, and under power it simply moves backwards and forwards like that. Connections on here for the solenoids and switching. As you can see in there, there's a tiny washer on a spring which allows connection between the track at the back and the two different tracks at the front in there. So a switch that operates when the solenoids operate. Connections on here, A, C, D, E, F, B, oddly. A and B are the power to the different solenoids, and C is then a common return. And then F is the common line for the switch, and D and E are the other side. So effectively D and E are power input to the frog, and F will go to the frog, so it will then receive either power from D or E, depending on which way it's switched over. This is the wiring diagram for the point motors. This is from Brian Lambert's website, but the idea is much older than that. It's a single wire operation with a common return. You can see here, this is the power supply input, which both go to the switch, which is a single pole double throw switch. And the way it works is that when power is applied down the single line, it goes through the capacitor and then through one of the diodes, which act as a directional control. And one of the solenoids is then activated, which throws the point, and then each point motor has a common return down here. So obviously you can't leave the power supplied to the solenoid motor, it'll burn out. And what the capacitor does, it charges up and then cuts off the current to the motor as it charges. And then when the switch is thrown the other way, over here, what happens is that the capacitor gets grounded and a circuit is formed which allows current to flow in the opposite direction through the other diode, which throws the point the other way as the other solenoid is activated, and it discharges all to ground. So the important things about this are, the advantages are that you've got a single wire running from each switch to each point area and a common return. The switch shows the position of the point motor because it stays in its thrown position. It's important when wiring this up that the standard position for the switch should be the discharge state, in other words to ground, so that the circuit's not charged up. That way when you apply power to the whole system, you don't suddenly get all the capacitors wanting to charge at once and draw in a huge amount of current. So what I've done is, for example, on the siding with main line running would be the negative position down here. When I want to operate the point, I apply power, and then when it's switched back to normal, everything discharges ready for being turned off.